Good morning, students. This class I am going to teach you about the derivation of Lagrangian equation of motion using Hamilton's variational principle. We know variational principle, that is, when a motion takes place, if it has many paths, to find out the exact path, this variational principle can be used. And we know the mathematical definition for variational principle. What is that? Delta I, that is equal to delta of integral t1 to t2 L into dt equal to 0. This is the mathematical expression for variational principle. We know that L is the Lagrangian. L is nothing but t minus v. Therefore, this equation, instead of L, we may write delta I, that is equal to delta of t1 to t2 t minus v into dt equal to 0. But t is the kinetic energy and v is the potential energy. This kinetic energy will depends upon the generalized coordinates qk and qk dot. This potential energy will depend upon only qk. It does not depends upon the velocity quantity. We already know this also. Now substitute. So instead of, in the place of t, we may write the above equation as t1 to t2. T is the function of qk dot minus v is the function of qk into dt equal to 0. Now, to solve this equation, we should use Euler's theorem. To solve the above equation, we use Euler's theorem. I think you all know about Euler's theorem. I will again explain you what is Euler's theorem. If there is a function f and it has three coordinates x, y and z. So, if I want to calculate the value of dou f, then according to Euler's theorem, how we will do this? First, this f will be differentiated partially with respect to x into delta x, plus this f is partially differentiated with respect to y into delta y, plus this f will partially differentiated with respect to ez and into delta ez. So this is Euler's theorem. So in order to find out the value of dou f, then dou f by dou x into delta x plus dou f by dou y into delta y plus dou f by dou z into delta z. This same method will be applied here to solve the equation. This equation. Now you see, this equation becomes delta of t1 to t2. Here t, first term t with respect to qk into delta qk. Then plus this t may be differentiated with respect to qk dot into delta qk dot. Then similarly for this, dou v by dou qk into delta qk into dt is equal to 0. Okay, so this above equation will be changed in the format of Euler's theorem. By applying Euler's theorem, we made this. Now, in the above equation, you separate this qk quantity separately and qk dot quantity separately. So, delta T1 to T2. Here first qk quantity dou T by dou qk, and this minus dou V by dou qk into delta qk separately. Then plus dou T by dou qk dot into delta qk dot. Okay, into dt is equal to 0. So we separated qk term separately, qk dot term separately. Now you multiply this integration term also separately for these two quantities. That is delta integral T1 to T2 dou T by dou qk minus dou V by dou qk into delta qk dt. Here this delta will not come, okay, because it went here itself, so it will not come. Now plus integral T1 to T2 dou T by dou qk dot delta qk dot into dt, that is equal to 0. So this integration term will be separately we applied for both the quantities. So integral T1 to T2 dou T by dou qk minus dou V by dou qk into delta qk dt plus integral T1 to T2 dou T by dou qk dot delta qk dot into dt equal to 0. Okay. Now this equation represents for a single particle. If there are more number of particles, say k particles, then we may use the summation symbol. We may use summation symbol in the above equation. Therefore, the above equation may be written as T1 to T2 summation of k dou T by dou qk minus dou V by dou qk into delta qk dt plus for this symbol, for this integration T1 to T2 summation of k dou T by dou qk dot into delta qk dot into dt is equal to 0. Now T1 to T2 k dou T by dou qk minus dou V by dou qk into delta qk dt plus here and small change, I am making a small change, delta k dou T by dou qk dot, this delta is there na, you remove this delta here, this qk dot is nothing but what is this, dqk by dt into dt, that is equal to 0. I am just changing this qk dot, I am making it as dqk by dt, a small change here. Okay, right. Now the equation may be written as integral T1 to T2 summation of K dou T by dou QK minus dou V by dou QK into delta QK dt plus summation T1 to T2 summation of K dou T by dou QK dot d by dt of delta QK into dt equal to 0. Now, that is, in the above equation, what I am simply now changing, this d by dt I am taking outside, and this delta I am multiplying it here with the qk. Understand? D by dt is taken outside, and this delta will be multiplied with the qk. That is this equation I have written now here, changed. Now, to solve this equation, you consider this term as the first term and this whole term as the second term. Okay? To solve this equation, I am just considering this first term as first variable and this term as the second variable. You make it as equation number A, capital A. Now, to solve this equation, I am now using product rule of integration. Product rule of integration. So what is the product rule of integration? If integral u v dt, then it may be written as u integral of v dt minus integral of d by dt of u into v dt into dt. So this is the product rule of integration. This is the product rule of integration. Now, you see this equation now. This is the u function and this is the v function. That's all. This is the u function. This is the v function. Now applying this product rule to solve this equation here. So what will happen? Integral T1 to T2 summation of K dou T by dou QK minus dou V by dou QK into delta QK into dt. The first term the first integral term, it will be written as it is. Now, this may be simplified using this product rule of integration. So, you see what will happen now? Plus. This value can be written as, how this will be written as? Integral, here you see, u integral v dt. U means this is u. So, u okay. Dou T by dou QK is u. Integral T1 to T2 v dt. V is this. So, d by dt of delta QK into dt. Okay. Then what will come? Minus this. Integral d by dt of u. U is nothing but summation of K dou T by dou QK. Integral v dt. V is nothing but this. So d by dt of delta qk into dt. Okay, this whole will come here and this dt is here equal to 0. Understand? So you see, this is u and this is v. Now I am using this product rule. What will be the value? This is u, u integral v dt. V is nothing but d by dt of delta qk into dt. Finished. Minus integral of d by dt of u. U is nothing but summation k dou t by dou qk. Integral d by dt, that is integral v. V is nothing but d by dt of qk. So v by d by dt of qk into dt. This dt is common, that is equal to 0. Okay, you understand now? Right. Here, now here this integration will come, but here there is no limit because this integration is within this only. Therefore, the integration limit will be applied to this integration, not for this. Okay. Now you see here the first term as it is, we will write t1 to t2 summation of k dou t by dou qk minus dou v by dou qk into delta qk into dt. So there is no change. Now this equation, how you may write? Summation of k dou t by dou qk integral of t1 to t2 d by dt and dt. So this integration and this differentiation will be deleted, cancelled to each other. Similarly, this integration, this differentiation and this dt will be cancelled to each other. So what will be the remaining term here? Summation of k dou t by dou qk into delta qk delta qk minus integral t1 to t2 d by dt of summation of k dou t by dou qk into dt equal to 0. Understand? So the remaining term will be written here, sigma summation of k, sigma k dou t by dou qk into delta qk minus integral t1 to t2 d by dt of summation of k dou t by dou qk into dt equal to 0. Now this term integral t1 to t2 summation of k, here commonly you remove dou by dou qk outside. So dou by dou qk into t minus v, then this delta qk is as it is, it will come, and dt, then plus what will happen to this term? The same term will come, summation of k dou t by dou qk into delta qk. It will come as it is. Now it will apply this limit t1 to t2 minus integral t1 to t2, this term as it is, it will come d by dt of summation of k dou t by dou qk into delta qk into dt equal to 0. Understand? Here I separated this separately, though t minus v is here. Then for this equation, summation of k, here you see, here this equation is there, here this integration, na? So this integration will become qk of t1 and t2. It is the meaning here. That is why I am here written t1 to t2. Now, basically, when a generalized coordinate is integrated with respect to t1 and t2, then it becomes 0. The generalized coordinate at t1 and t2 becomes 0. That means delta qk of t1 t2 becomes 0. Delta qk of t1 to t2 becomes 0. Then this term will become 0. Understand? This term will become 0. So what will happen for the remaining term? What it will come? How? You see, what will be the remaining term? Integral t1 to t2 summation of k dou by dou qk of t minus v into delta qk dt, then the term, second term will become 0 minus integral t1 to t2 summation of k d by dt of dou t by dou qk into delta qk into dt equal to 0. Okay, here I missed qk dot. Okay, this is qk dot actually. So in earlier point also you make it qk dot. I made it qk. It is qk dot. Right. Now summation of k t1 to t2 dou by dou qk of t minus v, because in this term I have removed summation of k and this integration commonly outside. So dou by dou qk of t minus v is there. Then another is what? Minus d by dt of dou t by dou qk dot is there. Then this delta qk into dt come outside equal to 0. So the above equation may be like written as. You remember here qk dot. So in this term, in earlier equations also I made just qk. So you please change it as qk dot for that place. Okay. Right. Now, because qk is generalized coordinate of position and qk dot is the generalized coordinate for a velocity. Therefore, you just make it qk dot. I missed qk. So it is qk dot. Now, yes. So now in this equation, summation of k integral t1 to t2 dou by dou qk into t minus v minus d by dt of dou t by dou qk dot into delta qk into dt equal to 0, or the above equation may be written as dou by dou qk into t minus v minus d by dt of dou t by dou qk dot will become 0. Okay, both are same. Now consider dou by dou qk dot into t minus v. Consider dou by dou qk dot into t minus v. This term may be written as dou t by dou qk dot minus dou v by dou qk dot. But we already know this is the kinetic energy T and V is the potential energy. T will depends upon what? Qk and qk dot. But V only depends upon qk and it does not depends upon qk dot. Okay. Therefore, this dou V by dou qk dot becomes 0. Understand? As the kinetic energy is dependent on qk and qk dot, but this potential energy is not depends upon qk dot. Therefore, dou V by dou qk dot becomes 0. So, here what will come? Dou by dou qk dot into t minus v, that is equal to, what is the remaining term? Dou t by dou qk dot. Understand? Dou t by dou qk dot. Now this dou t by dou qk dot will be substituted here. You make it this equation number capital B. I think this will be, you make it as equation number small 1 maybe. Now substitute the value of equation 1 in equation B for dou t by dou qk dot. So what will happen? B becomes dou by dou qk t minus v minus d by dt of dou t by dou qk dot. You substitute dou by dou qk dot of t minus v. Dou by dou qk dot t minus v. Understand? Equal to 0. Now t minus v we know it is L. Therefore dou L by dou qk minus d by dt of dou L by dou qk dot equal to 0, or multiply by minus, so this term becomes positive, this term becomes negative. Therefore d by dt of dou L by dou qk dot minus dou L by dou qk is equal to 0, which is nothing but Lagrangian equation of motion. So this equation represents the Lagrangian equation of motion, and this will be derived from Hamilton's variational principle. So this Lagrangian equation of motion is derived using Hamilton's variational principle. Even though these derivations are large, it is very simple only. So you do it in your home separately and you just study, and again you write these equations. It will become very easy, and the concentration should be given where qk will come and where qk dot will come, or where qk double dot will come. So it is very important in classical mechanics. So you just concentrate on the mathematical derivations. So this is derivation of Lagrangian equation using Hamilton's principle, Hamilton variational principle. Okay, in the next class I will teach a new topic in classical mechanics. Okay, thank you.